Good afternoon, everyone. This is the pre-launch news conference for NASA's IRIS mission. IRIS to be launched aboard an Orbital Sciences Pegasus XL rocket. And here to talk about the launch and the spacecraft is Jeffrey Yoder, the Deputy Associate Administrator for Programs for the Science Mission Directorate at NASA headquarters. Tim Dunn, the NASA Launch Director from the Kennedy Space Center in Florida for the Launch Services Program. Brian Baldwin, the Pegasus Launch Vehicle Program Director for Orbital Sciences Corporation. Gary Kushner, the IRIS Project Manager from the Lockheed Martin Solar and Astrophysics Laboratory in Palo Alto, California. And First Lieutenant Jennifer Kelly, the Launch Weather Officer from the U.S. Air Force 30th Operations Support Squadron at Vandenberg Air Force Base. And we'll begin first with Jeffrey Yoder.
Thank you, George. So IRIS, and you'll hear a lot more about the science aspects of it later, but it's the next mission on the next satellite to launch in our NASA Small Explorers program. And of course, the Small Explorers program is a innovative way to produce world-class science with collaboration. And I won't talk about the science aspects of it, but IRIS especially, when you look at the partnerships that have been involved that we have to achieve this great science, it involves government, private industry, academia, and international partners. So I'd like to just take a little time to thank the various partners that and members of the team. First, the NASA Explorers Program Office at Goddard, who oversees the Explorers activities for us within the Heliophysics Division. Second, the principal investigator institution is the Lockheed Martin in Palo Alto, and you'll hear more about that later. The NASA Ames Research is responsible for the ground commanding, flight operations, and data telemetry. The NASA Launch Services Program at KSC for the launch vehicle selection and the additional activities that you'll hear later on today. The Smithsonian Aerospace Observatory in Cambridge, Massachusetts for the design of the telescope for the spectrograph. Montana State University for the design of the spectrograph itself. The Norwegian Space Center and NASA's Near-Earth Network provide the ground station's communication. And Orbital Sciences Corporation for providing the L-1011 as well as the Pegasus that will launch this vehicle. As you can see, we have a dynamic, diverse team that I couldn't be more proud of. So with that, George, I'll turn it back to you.
All right. Thank you very much. And now to Tim Dunn, our NASA Launch Director from the Kennedy Space Center for the IRIS launch. Tim?
Thank you, George. I'm proud to be here today representing the men and women of NASA's Launch Services Program, and I'm thrilled to be the launch director for the IRIS mission. The solar science that IRIS uncovers will advance our understanding of our favorite star. Working alongside our Orbital Sciences Corporation colleagues, the engineers and analysts of NASA LSP take great pride in launching the IRIS mission. NASA has a terrific record flying on the Pegasus XL. We have launched 18 missions on this unique launch system. IRIS will be the 19th NASA mission on Pegasus and the 42nd overall Pegasus launch. IRIS will launch on a Pegasus vehicle dropped from the belly of the venerable L-1011 orbital carrier aircraft over the Pacific Ocean northwest of Vandenberg Air Force Base. I'd like now to show a video of the Orbital Sciences team building up the Pegasus XL launch vehicle and the mated IRIS spacecraft here at Vandenberg Air Force Base. Here you see a nice video of the processing facility, building 1555 here on Vandenberg. Gorgeous shot there of the first stage of the Pegasus XL vehicle. A nice shot from the rear looking forward. You see the two additional stages, the second and third stages ahead. We see a glimpse here next. This is the business end of Pegasus, and there's all three stages. Great shot there. Here's the mating of the first and second stages. You see Orbital's crew technicians working very carefully around the flight hardware. And this is the completed vehicle. There is the payload fairing installation around the IRIS spacecraft. You'll see the spacecraft in a later presentation. This is the installation of the completed vehicle onto the AIT, the Assembly Integration Trailer that we use to roll out to the runway. And this is just last week here. We have rollout on the 19th of June from Building 1555 and transport over to the hot pad processing area near the Vandenberg Air Force Base runway. This is coming onto the airfield here, and you see the L-1011 there, the Pegasus completed vehicle rolling on the AIT under the belly, going to be put on the hooks here and mated into a flight configuration here. It was a little bit windy that day. They've obviously turned the sound down on the wind here. And this is removal of the assembly trailer. And we're going to finish up a beautiful shot from the front side of the L-1011. The IRIS launch campaign has gone very well. Over the past week, the Pegasus team has been busy with launch preparations. Last Tuesday, on the 18th of June, the combined NASA and Orbital Sciences team held the flight readiness review where we assessed the preparations and readiness of the Pegasus XL vehicle, the L-1011 aircraft, range assets, and of course the IRIS spacecraft. After transport and mate to the aircraft, we performed the combined systems test with the spacecraft and rocket last Thursday. And just over the past 2 days, including this morning, we've performed 2 wet dress rehearsals to exercise and prepare the entire Pegasus IRIS launch team, including Orbital, Lockheed Martin, NASA, and the Air Force. We are currently working one open issue at this time. We are awaiting the final readiness of the power systems that supply Vandenberg Air Force Base facilities that support the Western Range Operations Control Center. An effect of the Central California Coast power outage that we experienced this past Sunday night was damage to the power systems that feed these critical range facilities. Repairs to the power equipment should be complete later today and allow the range team to perform the required L-1 configuration checks tomorrow. Due to this issue, we will delay our first launch attempt from Wednesday evening to Thursday evening. Tomorrow, we will conduct the launch readiness review for the IRIS mission. Senior managers from NASA KSC, Goddard Space Flight Center, Ames Research Center, and NASA headquarters, as well as Orbital Sciences Corporation and the Air Force, will assess the entire readiness of the mission, the rocket, aircraft, spacecraft, and range assets, to proceed with a Thursday evening launch. Given a go, coming out of LRR on Thursday, the crew would begin arriving on console mid-afternoon Pacific time. We'll begin our final launch activities at approximately 3 p.m. by preparing the L-1011 orbital carrier aircraft for takeoff. After Pegasus power on, aircraft engine start, and ground preparations are complete, the aircraft will take off 1 hour prior to launch and fly northwest toward the target drop zone. The launch crew here at Vandenberg Air Force Base and the aircraft crew will perform the final preparations of Pegasus and IRIS, including the FTS checks and switching IRIS spacecraft to internal power. Once in the target drop box over the Pacific Ocean, and after aligning the aircraft on a southerly heading, verifying altitude and airspeed, we will be ready for Pegasus release from the aircraft and first stage ignition Thursday evening at 7:27 and 34 seconds p.m. Pacific time, which is the middle of our 5-minute window. To summarize, the Pegasus XL rocket, the IRIS payload, and the aircraft are ready. Tomorrow we will assess range readiness at our LRR, and the combined government and contractor team is both prepared and excited to launch this important science spacecraft. Back to you, George.
Thank you, Tim. And now to Brian Baldwin, the Pegasus Launch Vehicle Program Director from Orbital Sciences Corporation. Brian?
Thank you, George. On behalf of Orbital Sciences Corporation and the Pegasus program, we want you to know how pleased we are to be here at this point in the mission. It's been hundreds of people and thousands of man hours to get to this point, and so It's been a great effort by the team, and we're pleased to be a part of that. We'll show you a short video in a moment here, but just to give you an idea of what happens in a Pegasus launch, when we reach the drop point and the command is given from the launch conductor to the pilot to release the Pegasus vehicle. Oh, here we go. All right. All right, so we drop in free fall for 5 seconds prior to ignition. That allows us an opportunity to arm our flight termination system. The motor will burn for about 68, 70 seconds. Here we are in second stage. Fairing will be jettisoned about 37 seconds into this burn. So you'll see the fairing fall away. At the end of stage 2 burnout here, we'll be going 12,000 miles per hour and be about 116 miles up. There you can see the separation, the next stage ignition. This is the third stage burning here. We'll separate, the spacecraft will be separated about 13 minutes into the flight. After successful insertion of the spacecraft, we will turn off our telemetry transmitters about 840 seconds, which is about 14 minutes into the flight. And we have a couple of other things to do prior to completing our particular mission. We will perform a collision and contamination avoidance maneuver. We'll back away from the spacecraft because both the spacecraft and the third stage will be orbital at that point. We'll back away to make sure that we have clean separation between the spacecraft. Then we'll about 1,300, 1,400 seconds into the mission, we'll go ahead and vent our tanks, RCS tanks, and we'll be done at that point. So we look forward to a great mission and a great science coming out of this effort. So back to you, George.
Thank you, Brian. And now to Gary Kushner, the IRIS project manager from the Lockheed Martin Solar and Astrophysics Laboratory in Palo Alto. Gary?
Thank you, George. I'm very proud to be here representing the entire IRIS project team. We're also excited to be here and prepare for launch. The first graphic I thought I'd show you is you saw in Tim's picture the fairing. This is what's actually inside the fairing. This is the observatory with solar rays deployed. The observatory is about 7 feet long and about 4 feet wide at the base, the spacecraft. With the solar rays deployed, it's 12 feet wide. Next picture. We will be in a sun-synchronous orbit. We'll be sun pointing the entire time, 97-degree inclination, and we pass over the same point on Earth about every 97 minutes. We're a small satellite. We're about 400 pounds, and we consume about 350 watts. In this picture you can see the instrument in the spacecraft. The instrument consists of the telescope assembly, which is in green, and the spectrograph, which is in light blue, and the spacecraft itself is in orange. Next slide. This is the instrument assembly here. You can see from the left of the white collar is the telescope assembly, and to the right is a spectrograph. And I'll have a graphic showing the breakdown of that. And the next one is a graphic of the instrument assembly. And in the next image, you'll see a cutaway. Let's see, do we get the next image? There we go. You'll see a cutaway. You can see some of the optics inside. And then the next image, you'll see the light paths. So the sun would be to your right. The light would enter that front door, hit the telescope on the left. The orange rays represent the telescope section. And then the left side is the spectrograph. The 4 different colors represent the 4 different spectroscopic channels we have. Supporting that, next image, we have the spacecraft, which I mentioned is 4 foot diameter, about 16 inches high. It's a full, complete spacecraft. The only thing we don't have is we do not have any propulsion. And the next image will show the expanded view of the various components inside. It's an aluminum bus with 8 bays, and in each bay we have several components. We have the flight computer, we have the power system, we have ACS components including star trackers, magnetometers, reaction wheels, and we also have the battery. So it's like I said, it's a complete spacecraft. Next image. This is how the observatory will look fully stowed, and that is how it looks inside the fairing. and that's with the solar rays folded up. And I think that's all I have for the graphics. And then next we'll show a video now. And the video will show us arriving at Vandenberg. This was on April 16th of this year, after finishing all the testing at Lockheed Martin, all the environmental testing. This is obviously us unloading from a truck on a special transportation frame. We're wrapped in protective material. We're contamination sensitive, so we have to maintain a clean environment until we're placed in the clean tent, which you'll see in a short moment. This is the team preparing to transfer from the transportation fixture over to what'll be the handling fixture. And this is the team. While they're doing the transfer, while we're at Vandenberg, after we ship, we do what are called functional tests. We make sure that the observatory survived its shipment. We exercise all the mechanisms. We check out all the systems. We also do tests with the Mission Operations Center back at Ames, so we can connect through the internet and do mission simulations, we call them. And then we also do, as we get ready to mate with the rocket, which you can see in the background there, this is us going into the tent, we do what are called integrated verification tests, where we connect electrically with the rocket and do tests to make sure we both communicate well. And then after we mate, we do more detailed tests called flight simulations. And here you can see the team getting ready to move the observatory over to the rocket, and they will mate to the third stage. Even though we're in a clean tent, we still keep some protective covering on it. And there's the front of the third stage and the rocket and the observatory being mated. There is the first half of the fairing being installed. That's a great shot of the observatory, the last shot you'll see of the observatory before they put on the right half of the fairing. And that is pretty much the end of the video. And the next graphic will show the timeline. Once we launch, as Brian noted, we 2 minutes later after launch we will separate, and then as Brian mentioned, 13 minutes later we will separate the fairing after 2 minutes. We will separate from the third stage after 13 minutes. 3 minutes after that we'll deploy our solar rays, and the third stage will do its walk away from us. And then we are supposed to be connecting with TDRS, but if we don't, our first ground station contact will be at 28 minutes. So we will be able to monitor these critical events either through TDRS, or we'll get our first acquisition in 28 minutes. And then about an hour and 13 minutes after launch, we will be pointed at the sun in what we call course mode, where we'll actually be on station, power positive, solar rays will be receiving their energy, and the telescope will be facing the sun. On the next graphic, what we do after that, we then power on the instrument on the second day, and for the first 21 days we are doing checkouts. We're doing like those functional tests we do on the ground. We're spinning wheels, we're checking out, we're doing various calibrations, and we open the telescope door on the 21st day. We don't do it until then to protect it from contamination. After the 21st day, we have 9 more days of engineering checkouts, and then we hand over to the science team. They begin their calibrations, testing their timelines, and then we begin the full science program, which is scheduled for 2 years. Then that is pretty much what I had to discuss. Back to you, George.
All right. Thank you, Gary. And now for a look at the weather forecast for Thursday. First Lieutenant Jennifer Kelly, our launch weather officer from the U.S. Air Force 30th Operations Support Squadron.
Thank you, sir. Good afternoon. June is a transition from spring into summer for Vandenberg Air Force Base, marked by fog and temperatures in the mid-60s. Currently, we have a low-pressure system west of British Columbia producing significant clouds and precipitation along the coast. The clouds associated with this low-pressure system will be pushed back to the northwest tonight and tomorrow as the ridge builds from the east. This will provide improving conditions and clearer skies by tomorrow afternoon. Looking at the satellite image, you can see cloud cover associated with the low-pressure system along the coast to our north, while to our south you see clearing associated with that high. Residual moisture will produce a layer of stratus clouds Thursday, with high pressure compressing that stratus layer and generating warmer temperatures at the surface. Models are agreeing that our primary concern for launch will be ceilings and visibilities decreasing as evening approaches. The forecast for June 27th will see improving conditions compared to today as that ridge builds in. This will result in lingering stratus clouds between 500 and 1,000 feet and visibility reduced to 3 miles. Winds remaining out of the northwest at 8 to 12 knots and temperatures in the low 60s. Along the flight path and in the drop zone, we'll see clear skies and little to no turbulence. This will produce an overall probability of violation for T0 of 20% with an area of concern for ceilings and visibilities. Thank you. Back to you, sir.
All right, thank you, Lieutenant Kelly. And we're ready now to take questions. Please give your name and affiliation when the microphone comes to you. We'll start here in the front with Nora.
Nora Wallace, Santa Barbara News Press. Mr. Dunn, could you go into a greater explanation about the power outage and the effect on the mission? Any details about who was out at the site when the outage occurred, and just a greater explanation?
Yeah, I can give an overview of the situation. I don't want to go into too many details. It's certainly range equipment, and someone from the base or the 30th Space Wing should address the specifics of that. And actually, I think we may have someone in the audience that can do that. But in general, there was an event. If you were on the Central California coast Sunday night, you were aware that we were without power for the period of a couple of hours, affecting the entire region, including obviously Vandenberg. Related to that, there were some, as power was restored on the base, it appears that there was an issue with equipment that feeds a transformer into the critical range facilities that took power down for that entire critical complex. So the Air Force and the wing have been working very feverishly, as you can imagine, since early yesterday morning. We just finished up a meeting right before this press conference on the go-forward plan, putting in place all the necessary activities to support a Thursday evening launch. That's probably the extent of what I could share with you. I do see Colonel Burton Catledge. He is the second Range Operations Squadron Commander. Colonel Catledge, anything to add? Do we have a microphone that we could... I'm going to put you on the spot.
No problem. I'm Lieutenant Colonel Burton Catledge. I'm the Second Range Operations Squadron Commander. What Tim said is correct. We had a fire in one of our electrical switching boxes, and it feeds about 5 transformers. There's a particular piece, a copper bus bar, to be specific, that has to be fabricated and reinstalled before we can apply power back to these buildings that flow our telemetry and through our microwaves and how we get information back from the range sensors. So obviously this is more of a safety hazard than anything else, and so we want to make sure that the piece that we have is correct. It's fabricated correct, which we're estimated to be back in Vandenberg this evening. Once that piece is installed and we've tested it and we brought up all the range equipments and we've gone through the extensive testing and rehearsing that we need to do, we feel confident that we'll be able to support a Thursday evening launch. So everything is going nominally. We believe that we're once these pieces come, that we'll be able to support that. But once again, safety is important, and we're going to wait until we have those pieces in place and the range configured before we move forward. Is there any questions?
Any other questions from the media for Colonel Catledge while we have him? All right. If not, thank you, Colonel Catledge, and we'll go on to other questions. Justin.
Hi, Justin Ray with spaceflightnow.com, both for Tim and for Brian. Could you talk a little bit about the future prospects for Pegasus beyond this launch, and do you view this as a sentimental launch of potentially being the final Pegasus?
I guess, Brian, I can make just a brief comment and then turn it over to you, obviously. So IRIS is the last manifested mission on the Pegasus launch vehicle, a launch vehicle that's been very good to NASA, and we certainly hope it's not the last. Brian?
Okay. Yeah, we hope it's not the last as well, by the way. But there are currently a couple of opportunities that we will have the opportunity, I believe, to propose on. So we certainly don't think this is the end, and look forward to additional launches in the future.
All right. Any further questions? All right. Janine?
Janine Scully, Santa Maria Times, the Lompoc Record. Are there any more Pegasus vehicles or in parts built and ready to be used, or would you have to restart the manufacturing line?
Well, we don't have a set of motors currently, so we would have to order another set of motors from ATK. There are a few primary parts that I have additional backups on, but it's not like restarting a production line. We build these on a 1 by 1 or 2 at a time, so we have a lot of common hardware with our other launch vehicles, so that we don't lose that expertise.
Nora, follow-up?
A follow-up on that. So typically in the history of spaceflight, there's something special put on a rocket if it's the last one, or some special ceremony. Can you explain if anything like that happened with this one?
Well, we don't consider it the last one, so there's nothing special on this one. So.
All right, any other questions here in the room? Justin, follow-up.
Just another question on the range. What's the availability on the range beyond Thursday if the issue isn't resolved, or if you have another scrub or something?
So we had 2 dates scheduled on the range, Wednesday and Thursday. Obviously, we'll not be using Wednesday. We'll go to our backup date. There are other customers on the Western Range that have scheduled tests booked on Friday and actually through the weekend. Obviously, if we are not able to get off on Thursday, we would hope to get another opportunity while we have the entire team assembled here and ready to go. We have begun discussions with other range customers and Colonel Catlich's personnel working through range scheduling. They're aware of our intent, so we'll let that process play out and see where we are, and hopefully we get a solid launch on Thursday night and we don't need to worry about Friday.
All right, I think we have a question on the phone from Lisa Krieger from the Mercury News. Go ahead. All right, looks like we will continue. That one is not at hand at any rate. Jennifer, have you got any questions from online? We have one.
This question is for Gary. Can you talk about any of the engineering challenges faced by the IRIS team preparing for launch?
In this time frame? No. IRIS these are one-off scientific instruments, so there's always some challenges. We had, let's see, I'm trying to think of a few. Early in the build, with the spectrograph is a very complicated instrument. We have 18 optics in there, so we did an early prototype of that and did vibration testing of all the optics. That one took us a little time to get together and calibrated. When we had the spacecraft, there were a few components that took a little extra effort. Some of our comm units required some extra work, and those are kind of the main ones. I'm trying to think. Is there anything else? Just the general, build flow. That's all I think of right now.
All right, we're going to take another attempt at the phone-in question. There's about a 3-second delay. Lisa Krieger from the Mercury News, want to give us another try?
Thank you. Wondered if you could explain for the layperson how IRIS will advance our understanding of the sun. What types of mysteries do you hope to solve?
We're going to have a science briefing, and the scientists will be up. Will you be able to stay on for that?
Yeah, we do have a science briefing coming up right after this one that'll go into more of that
if
background.
Not, I'd much rather have Dr. Teitel answer that question.
All right, have we any other questions here in the audience? All right, in that event, we're going to pause long enough to change the participants on the dais, and then we'll be right back with the mission science briefing that will answer just the question that she had. And that will conclude our pre-launch news conference. Stand by next for our mission site.